Hello dear students, today we are going to learn about current electricity. In this chapter, we have to learn about different concepts related to the current electricity. Those are what is electric current, potential difference, then Ohm's law, resistance, resistivity, resistance in parallel and resistance in series. So, these different concept you have to study in this chapter. First, we will see about the current electricity. Domestic appliances like fridge, electric oven, mixer, fans, washing machines, vacuum cleaner, roti maker, etc. have helped us by saving time and labor. All these devices cannot be run without electricity. So, electricity is a important factor in our life. Electricity is of utmost important in the modern world. We depend on it for almost everything in our day-to-day life. In order to avoid inconvenience faced due to the failure of power supply, hospitals, banks, offices and private institutes makes alternative arrangement with the help of generator. Electricity is used for running electric furnaces, electric motor and several other instruments used in industries. Not only human being but some animals also use electricity. For example, fishes such as eels use electricity to catch their prey and also for self-defense. The lightning that strikes the earth is an excellent example of natural flow of electricity. What if you could collect and store this electricity? We have to consider about that. Then we will see about potential and potential difference. If you see the level of water and direction of flow, you will get idea that flow of water is from higher level to lower level. The flow of electric charge between two points depend on a kind of electric level at those points, and these levels are called electric potential. A positive charge flows from a point of higher potential to point of lower potential. We have seen earlier that electricity flows due to conduction of negatively charged electrons. Electrons flow from the point of lower potential to a point of higher potential. A lightning strike is the flow of electrons from point of lower, that is negative potential, on the clouds to the point of higher, that is zero potential on the earth. So, in this picture you will see the free electrons. The free electrons move freely from atom to atom. Potential difference. Here the difference between high electric potential and low electric potential, that is positively charged conductor and negatively charged conductor. The difference between the values of potential at 2 points is called as potential difference. The unit of potential difference in the SI system is Joule. That's why 1 Joule equal to 1 joule upon 1 coulomb. Potential difference of a cell. The difference in potential between the positively and negatively terminals of a cell is the potential difference of a cell. This potential difference is caused by chemical reaction occurring inside the cell. The potential difference sets the electron in motion and results in flow of current. The potential difference between 2 points is equal to work upon total charge transferred, that is V equal to W upon Q. The Italian scientist Volta constructed the first electric cell. The unit of potential difference is named Volt in his honor. This is the Volta's simple electric cell. The unit of potential difference is volt, but very small values of potential difference are expressed in different units, that is in millivolt or microvolt. 1 millivolt equal to 10 raised to minus 3 volt or 1 microvolt is equal to 10 raised to minus 6 volt. Also, large values of potential difference are expressed in the following units, that is kilovolt or megavolt. 1 kilovolt equal to 10 raised to 3 volt and 1 megavolt equal to 10 raised to 6 volt. Current flowing through a wire. Here, wire is made up of different atoms. Wire is made up of atoms, and in that atoms there are electrons. These are the electrons which are in random motion. But when motion of the electrons after applying the potential difference to two ends of the wire, when we connecting this wire to two ends of these wires, if you connect it to the positive and negative charge, and if there is a potential difference between these two terminals, there is a flow of electrons from negative to positive terminal, and because of that there is a flowing of electric current. Electrons can easily move from one part of the conductor to its other parts. The negative charge of the electrons also gets transferred as a result of this motion. The free electrons in the conductor are carriers of negative charge. Then electric current. An electric current is a flow of electrons through a conductor. Electric current is a flow of electrons through a conductor. Quantitatively, current I is defined as the charge passing through a conductor in unit time. That's why if a charge Q is flowing through cross section of a conductor in time t, then the current I equal to Q upon T. It is if the unit of this current is ampere, and this is the expression of this charge is in coulomb and time in second, then ampere. 1 ampere equal to 1 coulomb upon 1 second. Current I equal to Q upon T. The unit of charge in SI units is coulomb and current is expressed in ampere. That's why the charge of electron is 1.6 into 10 raised to minus 19 coulomb. But with the help of this formula, we can say 1 ampere equal to 1 coulomb upon 1 second. And this is 1 ampere. What is 1 ampere? 1 ampere current is said to flow in a conductor if 1 coulomb charge flows through it every second. 1 ampere current is said to flow in the conductor if 1 coulomb charge flows through it every second. Here also a small values of current are expressed in the different units, that is milliampere or microampere. 1 milliampere equal to 10 raised to minus 3 ampere and 1 microampere is equal to 10 raised to minus 6 ampere. Even though electrons move from negative end to positive end, conventionally the direction of current flow is taken to be positive, taken to be opposite of the direction of flow of electrons, that is from the positive end to the negative end of the cell. The French mathematician and scientist Ampere conducted a number of experiments on electricity. Today, we can measure the current flowing in the conductor only because of his work. The unit of current is called ampere in recognition of his work. Then resistance. As shown in this figure, there are large number of free electrons in a conductor. They are constantly in random motion. When a potential difference is applied between the two ends of the conductor, these electrons start moving from the end at lower potential to the end at higher potential. This directional motion of the electrons causes the flow of current. Moving electrons strike the atoms and ions which lies along their path. Such collisions cause hindrance to the flow of electrons and oppose the current. This hindrance is called the resistance of the conductor. Unit of resistance. Ohm is the unit of resistance. 1 ohm equal to 1 volt upon 1 ampere. The German physicist George Simon Ohm established a law for measuring the resistance of conductor. In his honor, the unit of resistance is called the ohm. Potential difference and current are measured in volt and amperes respectively. The unit of resistance is called ohm and it is indicated by the symbol like this. Resistance of 1 ohm. If 1 ampere current flows through a conductor, when 1 whole potential difference is applied between its ends, then the resistance of the conductor is 1 ohm. If 1 ampere current flows through a conductor when 1 volt potential difference is applied between its end, then the resistance of conductor is 1 ohm. Then we will see about resistivity. At a given temperature, the resistance R of the conductor depends on its length, area cross section A, and the material it is made of. So resistivity is depend on the resistance of the conductor depends on its length, area of cross section, and the material it is made of. The SI unit of resistivity is ohm meter. If a resistance of a conductor is R, then R is directly proportional to L. Resistance is directly proportional to the length of the conductor. Also, resistivity or resistance is directly inversely proportional to the area cross section. That's why R proportional to L upon A. And here the constant proportionality, and it's called resistivity of the material. Resistivity of some materials are, for example, copper 1.7 into 10 raised to minus 8 ohm meter, nichrome 1.1 into 10 raised to minus 6 ohm meter, diamond 1.62 into 10 raised to 13 to 1.62 into 10 raised to 18 ohm meter. So these are the some resistivities of some material. Dear students, we will continue the part 2 of this chapter in tomorrow. Till we have to read the lesson which is in textbooks and we have to solve the exercise. If you have any doubts, you have to call me on this number. Please see the next part of this chapter for other concepts. Thank you.